So we want to find the equation for this, f composed of g of x, and we want to find the domain of it. So f of g of x is like saying f of g of x. f composed of g of x is like saying f of g of x. Blah. So anyways, I take my g of x and I plug it into f. That's the idea. G of x is x squared. So I want to plug that into f. So everywhere I see an x up here, I put an x squared. That was tough. Now, to find the domain, you've got to watch out. Are all the outputs of this going to work for the inputs in this? And they will, because there's on this one, you don't even have to worry about anything on this one. The x is not in the denominator, it's in the numerator. And you can add 2 and divide by 2 to any number. So the domain of this would be all real numbers. And this would give you all real numbers. So the domain of this guy would be all real numbers. Now if I switch it, if I say g composed of f of x, then that's like saying g of f of x, and f of x gets plugged into g, and that would be x plus 2 over 2 squared. If I plug it into g, now I can, if you look at this, there's nothing that's going to break this guy. You're going to add 2 and divide by 2, and you can square any number you want. So the domain of this one is all real numbers. And if it says interval notation, we've got to put it in interval notation, right? So either way, let's look at this one here. F composed of g of x. That's like saying f of g of x. G of x is x squared. So I replace it. Now, x squared goes into f. So it goes into f right there. So I cube it. It's minus 1. That would be x to the 6th minus 1. And now you can take the 6th power of anything. All the outputs of this would work inside of that. So the domain of this would be all real numbers. If I flipped it, g composed of f, I'm going to take f and plug it into g. So f goes into this. So x cubed minus 1 squared. That would be x cubed minus 1 times x cubed minus 1. So that's x to the 6th minus 1 x cubed minus 1 x cubed plus 1. So I wind up with x to the 6th minus 2x cubed plus 1. And the domain of that would be all real numbers. Or in interval notation, you write it like that. Okay, finally we wind up with something with, gosh, you gotta watch out your domain on this one because you're dividing by x. So if I'm talking about f composed of g, g goes into f. So this goes into f. 1 over x minus 4 divided by 2. Now, to simplify this, when you divide by a fraction, it's like multiplying by the reciprocal. So 1 times the reciprocal, which would be 2 over x minus 4, which equals 2 over x minus 4. Well, check it out. If your x value was 4, 4 minus 4 is 0. You cannot divide by 0. So, let's see. If I put 4 into this, I wind up with 4 minus 4 divided by 2. Well, that's 0. Now that output right here goes into f. Because remember, this is like saying f of g of x. So if I put a 4 in, I get a 0 out of g, and then it goes into f, and it kills f. You cannot divide by 0. So the domain of this composite function is not just 0, it is actually 4. 4 is the kryptonite for this guy. So you go from negative infinity to 4, put a u there, and 4 to positive infinity. So there's your domain for this one. Now if you flip it, g composed of f of x, well, remember, this is like saying g of f of x. So f goes into g. Well, f is 1 over x. Now 1 over x goes into g, and g was x minus 4 over 2. So 1 over x gets replaced, it gets punched in there, minus 4 over 2. So I just replace my x value in g with the f value. So that x becomes this function. So I would just leave it like that. Now, I wouldn't simplify it. That's good enough. Talk should take that. 0 will kill this because you can't divide by 0. And that makes sense because you couldn't put 0 into f to begin with. If you put 0 into f, it would kill it. And then you wouldn't have anything to put into g. So the domain of this composite function is different. It would be, the domain of this guy would be from negative infinity to 0, 0, positive infinity, with the parentheses at the end. Here's another one. We want to find f composed to g of x. So we'll plug g into f. This guy goes into f. That x becomes this. I can't write. Okay, that becomes this. Now I gotta write the rest of it. So there's my function, my new composite function. Now the domain, I can't take the square root of a negative number. Right there, that'll kill this whole thing. You can't. It'll be an imaginary number, and you can't. It won't work. So the domain of the composite is limited by the domain of this. So that's what we're going to have to write. So let's figure out what that would be. X has to be greater than or equal to negative 3. So, and that would actually be a bracket. So there's the domain of that composite function. What would it be if it was flipped? G composed of f. Well, that means you take f of x and plug it into g. So you take f of x and plug that into g. Let me get a piece of paper here. So f of x is this guy, and that x right there becomes x plus 1 over 3. So it gets replaced. So take f of x, and that becomes the x value in g. Okay, so there's what you got there. Well, you don't have to worry about dividing by 0, but you have to worry about where this is negative, because you can't take the square root of negative. Okay, so think of it this way. The domain of this is all real numbers, right? But any output you get out of this that happens to go into here, and you add 3 to it, and it's negative, it will kill the whole thing. So we have to worry about, well, what's under the radical is greater than 0, greater than or equal to 0. So I'm going to try to solve this out. So well, the first thing I reckon I'd try to do would be to move the 3. And I multiply both sides by 3 to get rid of this fraction. That would kill that. X plus 1 is greater than or equal to a negative 9. And then I'd subtract 1, right? So my x values have to be greater than or equal to negative 10. Interval notation, negative 10 to positive infinity. X has to be bigger than or equal to negative. So there's my interval notation. So check it out. There's all kinds of numbers you can plug into this, but if you plug anything that is negative 10 or bigger, you'll get an output that when you add 3 to it, it'll be positive. Now, if you put something in that's not in the domain, like say negative 11, negative 11 plus 1 is negative 10. Negative 10 thirds. Negative 10 thirds plus 3, well, that'd be like saying 9 thirds. So negative 10 plus 9 would be a negative 1/3. You can't take the square root of a negative number. That's why it's not in the domain. Say you picked 11, negative 13. negative 13 plus 1. And remember, negative 13 is not in the domain. The domain is supposed to be right here. This is outside the domain. I use negative 13. Well, if I put negative 13 in here, it'll work. Negative 13 plus 1 is negative 12. Divided by 3 is negative 4. Negative 4 plus 3 is negative 1. You cannot take the square of negative 1. Therefore, the domain would be limited to just these. Hope this helps.